Alright, so today we're looking at definite integrals by substitution. So our learning intention is to gain the knowledge in using substitution to integrate a function between 2 points. So we'll be successful if we can find the appropriate expressions to substitute, and sometimes they will give that to you, and then we're going to integrate using substitution, and then calculate the finite value for the area between these 2 points. Let's do some examples. Okay. So we want to calculate the integral between 1 to 2 of x over the square root of x squared plus 3 dx. So usually what we're going to do is we're going to replace this inside bit on the denominator as u. Then we're going to differentiate that. And we're going to make dx a subject. Okay. What we're also going to do is, so we're going to change this. I'm just going to leave that 2 and the 1 for a second. Okay. Now, when these 2 and this 2 and 1 is in relation to the x. So what I really need to do is I need to really change that. So if x equals 2, then remember u equals x squared plus 3. So that's going to be 2 squared plus 3, which is 7. And if x equals to 1, then u equals x squared plus 3. So we got 1 squared plus 3, which equals to 4. So what we're really going to do is we're going to integrate from 4 to 7 x over the square root of u du. Okay. Now we can cancel out these x's and take out a factor of a half. I can write that as negative a half. Okay. If I'm going to add by 1, that gives me a half. I'm going to divide 1 by a half, gives me 2. To the power of a half. Okay, well that cancels out, so I really have u to the power of a half from 7 to 4. So I really have the square root of 7 minus the square root of 4, which really is 7 minus 2 units squared. Okay. Or I really don't need to don't need that because it's an error, but yeah. Okay, and so there's the answer. Now what we could have done is we could have used the substitution and left the points later, but we'd have to substitute it back in and find, so at this point, let's just do an example. So here, instead of from 7 to 4, we would have done x squared plus 3 from 2 to 1. Okay. We'd still get the same answer. Alright, so this one says it gave us our u substitution. By using u equals sine x, evaluate the integral from 0 to pi 6 cos x sine x squared dx. So we've let u equals to sine x. If I differentiate that, we get cos x, and dx would be du on cos x. Okay. So here we go. If u equals sine x, when x equals to 0, right, we get sine 0, which would be 0. Okay. And then when x equals to pi on 6, we get sine pi on 6, and that's sine of 30, or sine pi on 6, which is a half. Okay, so what we're really doing is we've got the integral from 0 to a half of cos x. Sine squared x is u squared, yeah, and dx is du on cos x. Okay, well this cancels that, leaving me really the integral from 0 to a half of u squared du. So that's going to give us a third u cubed from a half to 0. So a third of a half cubed is 124 minus 0. So the answer is going to be 1 over 24. Okay. We want to find the area enclosed, so I'm going to leave my answer in units squared. So there's my function. The x-axis is in the lines. So what I want to do is I really want to integrate from 1 to 3, 3x x squared minus 1 to the power of 5 dx. Okay, so what I'm going to do is I'm going to let the inside be x squared minus 1. Differentiate that, and I get 2x. Okay. When x equals 3, and when x equals 1, so I'm going to go from 0 to 8, 3x, u to the power of 5, and dx is now du on 2x. Okay, those x's cancel out, and I can take out the factor of 3 on 2, which raise the power, divide by the coefficient. Okay, so 1/6 of 8 to the power of 6 minus 0, so it doesn't really matter. Okay, times that by 312 gives us 65,536 units squared. Okay, and that's it. Good luck.